Hello guys, my name is Pepson and I'll be taking you through introduction to programming. These tutorials are brought to you by BIT from Blantyre International University. So in this section, I'll be taking you through introduction to programming, the language generation overview, examples of computer programs, and program development. So what is a program? A program is a set of instructions that a computer follows in order to accomplish a certain task. These instructions are typically written in a programming language, for example, C++, which is a formal language used to communicate with a computer. Once a program has been written, it can be executed or run by the other computer, which then perform a desired task according to the instruction provided. So program ranges from different proximity, simple script that can perform a single task, to a large software application that can contain millions of lines of code. So here is an example of an instruction just contains few lines of code. In this instruction, we're trying to instruct a computer to take two numbers and add them and give us the sum. So as you can see, we have enter the first number, then it outputs the first number, then enter the second number, then it outputs the second number, then add those two numbers and give us the sum. So that's a simple code for an instruction. So programming is a verb, while a program is a noun. So when we're talking about programming, we're talking about the art of modeling the real world scenarios in order to come up with instruction that can be carried by a computer. So programming can be seen as the process of translating real world problems into a language that a computer can understand or can execute. The goal is to create a set of instruction called a program, as I said earlier on. So that tells a computer what to do in order to solve a specific problem that you're trying to accomplish. So when it comes to programming, it requires logical thinking, problem solving skills, and you have to be creative as well. So language computer understand. So computer do not understand the human language, like we talk about English or whatever language you might think of. Computer do not understand that. Computer have their own language they understand, which are called the binary numbers, which we're talking about zeros and ones. So we talk about 0001, 1001. Those are kind of languages computer understand. So example of programming language, we're talking about C#, Python, Java, C++. Those are kind of languages a computer understand. So as you are seeing in the illustration there, you input a word, for example, your name. The computer does not save the actual name; it saves it in form of binary numbers. The language generation overview. So we have the first generation, which is also known as machine code or assembly language. This consists of instruction and address that are specific to a particular computer hardware. So once that language was written in this computer architecture, cannot be used in another computer architecture. So machine code is a low-level programming language that is directly executable by the computer central processing unit. So the second generation assembly language is a low-level programming language used symbolic instruction and addresses to present machine code instruction and memory locations. So in this second generation, the language was more human reliable and easier to understand and maintain compared to the first generation. Third generation programming language are high-level programming languages. These languages are more abstract and easier to use than the first and second generation. The third generation language supports structural programming concepts such as loops, function, and conditional statement, which makes it easier to write and write complex programs. Fourth generation programming languages are high-level programming languages that designed to be more declarative and more user-friendly than the third generation languages. So in this generation, they are often used for a specific application such as databases, management, report generation, data analysis. This fourth generation focuses on what needs to be done rather than how it need to be done, making them more user-friendly and easier to learn for non-programmers. Now, the fifth generation programming languages are high-level programming languages that are designed to enable computer to reason and learn like humans. So in this generation, we're trying to focus on artificial intelligence, further logics, which are like techniques for modeling human thoughts and decision-making processes. So this generation intend to enable users to communicate with computers in a natural language rather than requiring them to learn a specific programming language. So we're talking about the computer understanding what we're trying to say, understanding our natural language. For example, trying to speak to the computer in your mother tongue languages. So the computer should be able to understand you. So this is the goal for the fifth generation computer programming language. So here we are at the examples of computer programs. So there's so many computer programs, and you have been using them in your daily life. As long as you interact with your phone, interact with your computer, use computer programs. So we're talking about word processors. Even WhatsApp too, yeah, it's a phone program, but it's also a set of instructions. So those two are computer programs. So we're talking about spreadsheets, image editors like Photoshop, video editors, web browsers, antiviruses, all those computer softwares that you know are computer programs. Program development. So in program development, you're trying to look at the processes a programmer needs to follow before and during program development, during writing a program. So some of the processes a programmer needs to follow before writing a program are output required by the user. So once you're trying to solve a problem, you know, okay, I need these inputs and I need this process to process the input, the data, and now I'll need the end results. So in this requirement, you're trying to look at the end results after your program has processed the data. What is the user requiring from that program once he had processed the input? What is the user requiring from that? So that's output required by the user. So the process required producing the output, we're looking at, okay, now you have the input. How will that data be processed? What process are you going to use to digest the data? So you're looking at the algorithms that you're going to use. So input data to be processed, we're looking at what kind of data, what type of data will your program be allowing. So are you going to be using text-based, image-based, video-based? So whatever problem you're trying to solve, you need to see and understand your inputs, because it's your inputs that will take you to the next step of what process to be used or what algorithm to use, and to take you again to the last step, what output will be like. So you need to understand the input data to be processed. Program development process. So in this process, the programmer needs to understand the processes required during program development. So requirement analysis is the first thing. In this stage, the programmer needs to gather and analyze requirements from stakeholders, users, and customers. The goal of this is to define the problem the software application will solve, identify the key features and functionalities required, and then establish any constraints and limitations. So the other thing is design. Once the requirements are clear to the programmer, the development team or the programmer himself will create and design a software application. The design will typically include overall architecture of the application, user interface, data models, and any algorithms or business logics required. And then we have coding. In coding, now after understanding the requirements, after having the design, the team or the programmer needs now to write the code for the software application based on the design. Typically, it involves writing in a specific programming languages using development tools and libraries. So another thing is testing. So in testing stage, once the code has been written, it needs to be tested to ensure that it functions as expected and it meets the requirement defined in the first stage, which is requirement analysis. So this includes unit testing, integration testing, and system testing. The last thing is implementation and support. So after testing is complete, any bugs or issues have been resolved, the software application is deployed to the production environment. Once software application is live, it also requires ongoing maintenance to ensure that it continues to function correctly and meets the user requirements. So in the next tutorial, we'll be looking at programming terminologies, compilation versus interpretation, algorithm, and development.